Welcome to Cookies Maths and Science Hub. In this video today, we'll be discussing molar ratio problems. That is, how to use molar ratios to solve for unknowns, whether they're moles based, concentration based, or mass based. So, what do we mean when we say molar ratios? This term is used to describe the ratio of moles from one chemical in a reaction to another. Let's look at an example now. In this reaction, we have 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid to produce 1 mole of sodium sulfate and 2 moles of water. As you can see, the number of moles is represented by the coefficients in our equations. That is, the numbers before the chemicals, the big numbers, not the numbers underneath, which are known as the subscripts. So, if we were to pick 2 specific chemicals, and let's look at our reactants, that is what's on the left side of the arrow. We have sodium hydroxide and sulfuric acid. Sodium hydroxide has a 2 in front of it, while sulfuric acid has nothing in front of it, which is equivalent to having a 1. We would say in this case that there is a ratio of 2 to 1 between the sodium hydroxide and the sulfuric acid. Additionally, we could say there is a ratio of 1 to 2 between the sulfuric acid and the sodium hydroxide, going back the other way. Looking at another example within this equation, we have 2 moles of sodium hydroxide and 2 moles of water. So we would have a 2 to 2 reaction, or more simply put, a 1 to 1 reaction. This shows us that we can simplify down our ratios when they're higher numbers. This will be very helpful for us in the problems that are to come. Given that these ratios require the number of moles to work, we need to be able to find the number of moles in a variety of different situations. This will involve 2 distinct formulas. Our first formula is that the number of moles is equal to the mass over the molar mass of a specific compound, element, or molecule. Our second formula is the number of moles is equal to the concentration of a particular compound multiplied by the volume of that particular compound. These 2 formulas are all that are required for solving these molar ratio problems. At times, you will need to rearrange them, so basic algebra skills are necessary for this kind of chemistry. There are 4 key steps to solve any molar ratio problem, and they are: first, you must balance the equation. Only when the equation is balanced will the ratios be correct. Then, you will find the moles of the known substance. In the question, you will always be given some sort of idea of which substance is already known, and then use this to calculate the number of moles of that substance. This might be the grams, concentration, volume, and molar mass of that substance. Then, you complete the molar ratio to work out the moles of the unknown. Once you know the moles of one of the substances in the reaction, you can then use ratio between that and whatever you're trying to find out how many moles that unknown has. Then the question might ask you to find the mass or concentration of that unknown, and you simply convert using those equations as required. Okay, let's get into our first example now. This question gives us 3 moles of cesium reacts with nitrogen as shown below. How many moles of cesium nitride, CS3N, are produced? And we are given the chemical reaction CS plus N2 gives CS3N. So, our first step, using our steps, is to balance the equation. Now, I'm not going to go through the balancing for each one of these equations. However, I'll have a video up soon that goes through balancing equations. So in this case, we then have 6CS plus N2 gives 2CS3N. And you can see we have 6 cesium on the left, 6 cesium on the right, 2 nitrogen on the left, and 2 nitrogen on the right. Therefore, we have balanced equation. Now, the second step is to find the moles of our known substance. The question gives us our number of moles. So in this case, it gives us the number of moles of 3 moles of cesium. We then have to complete the molar ratio to work out the moles of our unknown. So we're asked to find the moles of cesium nitride, and we can see in this case we have a 6 to 2 ratio. This simplifies down to a 3 to 1 ratio, and as we have 3 moles of our known, and it's a 3-to-1 ratio, all we have to do is divide that by 3, which gives us 1 mole of CS3N. In this case, step 4 is not required, as we are just finding the number of moles. Okay, in this example, which is a mass to mole example, we are given that ammonia reacts with oxygen to create nitrogen gas and water. If 40 grams of water is produced, how many moles of ammonia were required? Now, in cases like this, you might not always be given the reaction, but I'll provide it here to make it a bit easier for us. So it's NH3 plus O2 gives NO plus H2O. Balancing out that equation, again, I'm not going to go through it step by step, but then we'll have 4NH3 plus 5O2 gives 4NO plus 6H2O. Now, step 2, we need to find the moles of our known substance. In this case, we're told that 40 grams of water is produced. As we know its mass, we can use N equals M over M, where little m is mass and big M is molar mass. So that gives us our number of moles is equal to 40 divided by, or over, 1.008 times 2 plus 16, which gives us our N equal to 2.22 moles. Now, in this case, we're asked to find ammonia, which means looking at our balanced equation, we have a 6-to-4 ratio. Simplifying that down, which you can do by dividing both 6 and 4 by the lowest number, so in this case 4, we will have a 1.5-to-1 ratio. So all we have to do in this case is then divide our 2.22 by that 1.5, as we're going from the 6 to the 4. In this case, the 1.5 to the 1, which means we need to divide using our number provided. This gives us 1.48 moles of NH3. As the question asks for the number of moles, step 4 is not required in this example. Okay, so in this example, we are told sodium reacts with HCl. If 12 grams of sodium reacts, what mass of H2 is produced? Now again, in a question like this, you'd be expected to apply your acid-base reaction laws to work out the product and write out the full equation. I'll provide it here for you to make it a bit easier, and as this video focuses only on molar ratios, we can talk about the acid-base predictions another time. So our reaction is Na plus HCl, or sodium plus hydrochloric acid, gives sodium chloride, NaCl, plus hydrogen gas, H2. Balancing that equation out, we have 2Na plus 2HCl gives 2NaCl plus H2. Okay, so that's our first step, done. Our second step is to find the moles of our known substance. So we can see in the question we're given the mass of sodium, and because we automatically know its molar mass from the periodic table, we can use that to find its number of moles. So N is equal to mass over molar mass. N in this case is equal then to 12, our grams of sodium, over our molar mass of sodium, which is 22.99, which gives us our N value of 0.522 moles. Okay, then we go on to step 3, which is completing the molar ratio to work out the moles of the unknown. In this case, our unknown is hydrogen gas, or H2. That is what we're trying to find out. So we have a 2-to-1 ratio, as we have a 2 coefficient in front of our sodium, and no coefficient, or a 1 coefficient in front of our H2. As such, we simply divide our number of moles by 2, which gives us 0.261 moles of hydrogen gas, or H2. However, we need to apply step 4 in this case, as we're asked to find the mass of H2. So once again, using N is equal to mass over molar mass, we rearrange for our mass, so our mass will be equal to our molar mass multiplied by our number of moles. In this case, our number of moles is 0.261 multiplied by 1.008 times 2, so our mass equals 0.526 grams. Okay, in this example, we have sulfuric acid reacting with 24 mils of 3 moles per litre potassium hydroxide. How many moles of water are produced? Again, you'd be expected to predict this using your acid laws, but in this case, I'll provide the equation. So we have H2SO4 plus KOH gives K2SO4 plus H2O. To balance this equation, we simply need to put a 2 in front of our KOH and our 2 in front of our water. So we have H2SO4 plus 2 KOH gives K2SO4 plus 2 H2O. So our step 1 is complete. Now, step 2 is find the moles of the known substance. In this case, we're given both the concentration and the moles of our potassium hydroxide. So we will find that is our known substance, and we will find our number of moles by using N is equal to CV, or N, our number of moles, is equal to concentration multiplied by the volume. So N will be equal to 3 times 24 times 10 to the negative 3. Remembering that in concentration, we make sure we use liters. So I've just converted the mils there by 10 to the negative 3, which gives us our N value of 0.072 moles. Now, we're asked, step 3 is then to apply the molar ratio. So we're asked how many moles of water are produced. In this case, we can see the ratio between potassium hydroxide, KOH, and water is 2 to 2, which means we have a 1-to-1 ratio, simplifying them down. This means that we have the same number of moles, and therefore 0.072 moles of H2O are present. Step 4 is not required, as we are asked to find the number of moles, and no further calculations are needed for mass or concentration. Okay, last example now. This one's a concentration to concentration example. So we have 80 mils of ethanoic acid reacting with 3.2 moles per litre of a 35 ml calcium carbonate solution. What concentration of ethanoic acid reacts? So again, you'd be expected to use your acid laws to write this one out fully, but we have CH3 COOH plus CaCO3 gives CH3 COO, and 2 of that grouping, Ca, plus CO2 plus H2O. Balancing it out simply requires a 2 at the very start in front of our ethanoic acid to balance out the entire equation. So that is our step 1 completed. Now, step 2 is finding the number of moles of our known. So looking at our question, which one do you think we know the number of moles of? Or we can find out. Is it ethanoic acid or our calcium carbonate? In this case, it'll be our calcium carbonate solution, as we have both its concentration and its volume, which are 2 essential ingredients to finding the number of moles. That way we can use N is equal to CV once more, which gives us N is equal to 3.2 times 35 times 10 to the negative 3, remembering that our mils must be converted to litres here, which gives us our N, or our number of moles, is equal to 0.112 moles. We then move on to step 3, which is complete the molar ratio to work out the moles of our unknown. In this case, we have a 2-to-1 ratio. That means we must multiply, in this case, because we're going from a 1 ratio to a 2. So we must multiply our number of moles by 2. This gives us 0.224 moles of our ethanoic acid, or 0.224 moles of CH3COOH. We have to use step 4 in this case, as we're asked to find the concentration of this ethanoic acid. So our number of moles, once more, is equal to our concentration times our volume. Therefore, our concentration is equal to our number of moles divided by our volume. Looking back at the question, we are given the the volume of our ethanoic acid. So our concentration will then equal our number of moles, 0.224, over our volume of that ethanoic acid, which in this case is 80 mils, or 80 times 10 to the negative 3 when converted to litres, which gives us a concentration of 2.8 moles per litre. Thanks for watching. Hopefully you now have a good solid understanding of how to use molar ratios to solve for unknowns in chemical equations. Hope to see you soon.